Good afternoon, students. Welcome back again into my Applied Science College channel. Today we are going to proceed with the series of chemistry, and we are on Titration Practical number 11. So I'm just going to take you direct to the procedure so that we can be able to discuss this paper and we see how these questions are supposed to be answered. Last time I gave you some titration practical and you saw we discussed about it. It was about the redox titration and we discussed it very well. But this time round we are going also to look on another titration practical, but not the redox titration. It's just a normal titration. Let me take you through the procedure without wasting time. Otherwise, welcome again. Let me just go through what you are provided with, and then I take you through the procedure. 1, you have the following solutions. You are provided with solution M, hydrochloric acid, and then solution N containing 0.2 molar of sodium hydroxide, 0.2 molar of sodium hydroxide, and then also you are also provided with 0.6 gram of impure carbonate solid P. So you are required to determine the concentration of solution M in moles per liter and the percentage purity of the carbonate solid P. So let me just take you through the procedure slowly as we go by. Procedure: fill the burette with the solution with the sodium hydroxide solution, which is solution N, and then pipette 25 cubic centimeters of hydrochloric acid solution M into a conical flask and add 2 to 3 drops of methyl orange indicator. Titrate the solution M in a conical flask with the solution N and record the readings in the table in table 1. Then you repeat the titration 2 more times and complete the table. So this is the table. This is the table that you are supposed to be, that was completed. Let me just show you. Let me just put it how it's supposed to be. It's supposed to have 1 decimal point, at least 1 decimal point. So we did the entire practical and we found the figures that you can see on the table. And then we went ahead and calculated the average volume of that solution N. Remember, solution N was sodium hydroxide. So it was the one that was placed in the burette and then pipetted against the acid, hydrochloric acid. So we found the average volume as 25.0. That is the average volume. So after the cubic centimeters, 25.0 cubic centimeters. Let me just put it clear so that you can be able to see. That is 25.0 cubic centimeters. And then we were instructed to answer question number. We were instructed to calculate the number of moles of solution N used. So if you have been given such kind of an equation, you have been told to calculate the number of moles. You will just simply do like this. You simply just you ask yourself, if 100, if 1,000 cubic centimeters has 0.2 moles, like that. What about in 25? So you just ask yourself, what about in 25 here? So you just you come this side and then you do like this, 25 times 0.2 divided by 1000. If you do your mathematics very well, you will end up with something to do with 0.005 moles. 0.005 moles. The way I've done like on that, like that. So number of moles of solution M used. So we are on C. Number of moles of solution M used. The number of M of solution M used, it is just since their mole ratio is 1:1, let us see how that equation is supposed to be written. You write it like this, and then plus HCl, it is giving you sodium chloride plus water, which is a liquid. This is an aqueous, this is also an aqueous, and then also this one is an aqueous. So you make sure you write the states. As you can see, the reactant sides and the product side, it has balanced. The equation is balanced. The number of atoms on the product side and the reactant side, they are just okay. So the mole ratio is 1:1. Since we found the number of moles of sodium hydroxide on this side, on the here as 0.05, which means we just take 1/1 times 0.005, which is 0.005 moles. Since their mole ratio is the same, so the number of moles are also going to be the same. As you can see there, 1/1, because of the mole ratio being 1:1. And you remember to write the states when you are reacting this equation, because it is aqueous, and then the liquid, water. On the product side, we only get water and sodium chloride as the products of that reaction. Then we come to the concentration of solution M in moles per liter. The concentration of solution M in moles per liter, then we need now to calculate the molarity, or just the concentration. So we need to ask ourselves if 25 cubic centimeters, can be able to give us it has 0.05 moles. What about 1,000? Let me put it. What about in 1,000? 1,000? What about in 1,000 cubic centimeters? Remember, this is the concentration of the molarity. So we cross multiply this one times this over that. So it's going to give us 1,000 times 0.005 moles over 25. Let me put it over 25, which is going to give us, if you do your mathematics very well, you will end up with something to do with the 0.2 molar. Let me just show you very clearly. The paper was sliding as I continue to calculate. So that's how it's supposed to be calculated. You take that 1000 times 0.005 moles and then over 25 so that you can get 0.2 molar. So that's the concentration of solution M. Okay, so this is now we are going to procedure 2. Procedure 2, remember, and it reads, using a measuring cylinder, measure out 100 cubic centimeters of solution M into 25 cubic centimeters beaker. Add all solid P into the beaker containing solution M. Swirl the mixture and allow the reaction to proceed for about 4 minutes and label this solution Q. Pipette 25 cubic centimeters of solution Q into a conical flask. Add 2 to 3 drops of methyl orange and titrate with the sodium hydroxide solution N, which is solution N. Record the results in table 2 below and repeat the titration 2 more times and complete the table. So after you have completed the table, that table, it is supposed to be, they have indicated formats there. So we did that titration and we found the following figures. So remember also always to follow the law of titration, because always the table is supposed to be in 1 decimal point or 2 decimal points. So if you have decided it is in 1 decimal point, it's supposed to be 1 decimal point is supposed to be maintained throughout the table, and the table must always be complete as it's shown below. So we did that, and then we found the average volume as 16.0. 16.0. We put it very clearly. 16.0 cubic centimeters. That is what we found as the average volume. So we have been instructed to calculate the moles of solution N used. The moles of solution N used. So we went ahead and did that. So for us to get the number of moles of solution N used, we are supposed to take 1,000. We ask ourselves if 1,000 cubic centimeters has 0.2 molar. What about for 16 now? 16.0. So we cross multiply. We take 16 times 0.2. We divide by 1,000, and then you close your brackets. Then, if you do your calculations very well, you will end up with the 0.0032, assume this, 32 moles, like that. You will end up with the 0.0032 moles, like that. So then we went to an extent of also solving Roman 2 of that part 2, procedure 2. So we were told to also calculate the moles of hydrochloric acid in 25 cubic centimeters of solution. We were told to calculate those number of moles. So since we know that the mole ratio, the reaction was sodium hydroxide plus HCl, it was giving us sodium chloride plus water, which is a liquid, and then this is an aqueous, and then this is also an aqueous, this is also an aqueous, and then the mole ratio is 1:1. So, therefore, the number of moles of HCl in 25 cubic centimeters, This one is aliquot of solution Q is the same as the number of moles of N used in titration. So the number of moles are also going just to be like as these ones here. These ones. So we are just going to take 1 over 1 times 0.0032 moles. So it's giving us 0.0032 moles. And then we were told part 3 to calculate the number of moles of hydrochloric acid in 100 cubic centimeters of solution Q. So in this case, if you have been told that way, we are supposed just to ask ourselves if 25 cubic centimeters, it has 0.0032 moles. What about in 1,000? So we do the same, we cross multiply. Then we divide everything by 25, so that if you do your calculations properly, you will end up with the 0.0128 moles as your final answer. Remember, it was in 100. So these are the number of moles that are in 100 cubic centimeters of solution Q. Then, number 5 of that part of procedure 2, we were told to calculate the number of moles of hydrochloric acid in 100 of original solution M. That is 1 mark. I think it's supposed to be 1 mark. So, in this case, we will just ask ourselves if 0.2 it has 1,000 cubic centimeters. What about in 100 cubic centimeters? What about in 100 cubic centimeters? Then we take 0.2 molar. Remember 0.2 molar, it was the molarity that we found initially. This one here, 0.2, this one here. So it is still the one that we are still using here. And then we multiply it by 100 over 1,000 cubic centimeters. So if you do your calculations properly, you will end up with something to do with the 0.02 moles. So it's equals to 0.02 moles. Last but not least, we are told also to calculate the number of moles of hydrochloric acid that reacted with solid P. That is 1 mark. So you just take the first moles, these moles here, this mole 0.02, that one, 0.02 minus 0.02, we minus 0.128. We minus this one. Let me use the pen, these ones. So it's going to give us 0.0128, which is equals to 7.2 times 10 raised to power negative 3. All these are moles. That is the answer, this one. So you can see how I did. This is 0.02 moles. This 0.02 moles, they are these ones here. They are these ones, 0.2 moles, these ones. So are the ones that we subtracted from these ones, and then we found 7.2 times 10 raised to power negative 3 moles. So for those short remarks, let me just summarize to take you through the entire process slowly, so that you can be able to read it on your own like that. I came up with the whole calculations, and then we went to part 2 of that question paper, and then we did our titration. We got on the second table 16.0 cubic centimeters as our final average volume, and then we did those calculations like that. So these are the answers. Those ones are the answers, the ones that have got 2 lines. These are moles, remember? So these are moles. I didn't have a big space to write the number of moles, and the paper was also sliding. And then on the other side also we did that final. So that is what I have done so far, and I'll be coming to you with more virtual discussions in as far as titration is concerned. Otherwise, remember to subscribe, to like, and also to give some remarks just down the video. If you have any addition, you can be able to do so. Otherwise, I just want to thank you, everyone who is following me online. Thank you, and have a good afternoon. Bye-bye.